All right, friends, this is our last section of this chapter, graphing logarithmic functions. So you can now see that there's lots of great questions to practice here, and the Go formative 14 to 17 would be good. And you can see now that all questions in the Go formative can now be completed. So if you'd like to retest, make sure your Go formative is up to date. And so here we go. We're going to look at logarithmic graphs and graphing logarithmic functions. Okay, so you know all your log laws by this point, and now we're just going to make sure we can graph a logarithmic function. Okay, so we've done all these things here. And so first off, when you type in y equals log base 2 of x into Desmos or a graphing calculator, here's what you're going to see. And remember that basically when we're graphing y equals log base 2 of x, we're also graphing x equals 2 to the y, which is its inverse. And if this was base 3, then this would be base 3 here as well. So let's just see if we can make sense of it. So basically when y is 0, x would be 1. When y is 1, x would be 2. When y is 2, x would be 4. So that's what we're going to see here. And when we go the other way, when y is negative 1, we're at a half. So this is what the exponential graph looks like. So when I'm graphing exponential functions, I actually often might convert in my mind to exponential. That's just the way I like to think about it, but there's lots of ways to think about it. That's just mine. So if you were to looking at this, you can see it has an x-intercept. At 1, its domain is restricted. Remember, we can't take the log of a negative number, so that has to be greater than 0. The range is all real numbers, so there's no restriction on what that exponent could be or what y could be there. There is an asymptote, and this time it's at x equals 0, that vertical line there. And using Desmos, you could see that those key points. Let's see if there's anything here that's, there's not too much there. For us. So we're just going to leave it there. Let's continue. So you'll be asked to graph these with transformations. So if we took this graph here, describe the change to graph when x is replaced with x minus 1 and y is replaced with y minus 2, what would happen? Of course, pause the video and answer that for yourself. It would, of course, translate 1 unit to the right and 2 units up. So there you go. Okay, this exercise here is just making sure you know how to find the coordinates there. And what I like to do, and as a beginner you might like to do this as well, is I convert that to exponential because it's something we're comfortable with. And when we put 0 in for y, we're going to get we'll get 1 for x, and when we put 1 in for y, we're going to get 2 in, and so on. So we could leave that for you to do on your own. Okay, now is where we get started. Now what we're going to do is we're going to sketch these graphs. Okay, so what I'm going to suggest, and notice that this is base 3 here. So I'm going to ask you to go ahead and graph it. Interesting, that graph is not helpful. That should say base 3. And that's a base 2. I'm curious to see what I did over here. Okay, so I used base 3. So that graph was not particularly helpful. So here's what I'm going to suggest we do. We know that this plus 1 simply shifts the graph up 1. And we know that the x minus 2 moves it to the right 2. So from this point here, if I see this as my origin, all I need to do is graph x equals y to the 3. So I'm going to write that down. X equals y to the 3. And by that, of course, I meant 3 to the y. Okay, so basically, I'll notice here when y equals 0, x equals 1. When x equals 1, y equals 3. When y equals 2, y would equal 9. So keep that in mind. So from this point here, when y equals 0, x equals 1. So 3 to the 0 is 1. 3 to the 1 is 3. 3 to the 2 is 9. 3 to the 3 is 27. And that's how we sketch this. Alrighty. So So these two are not connected. That is not a great help. That's not a helpful graph there. Okay, so now what we're going to do is, given this thing, what are we going to ask you? What's the domain of that? Well, we know that for these functions that you can't take the log of a negative number, so we'd have to say that the x is larger than 3, and the y-intercept, there would not be a y-intercept. And it sure would be nice to have a sketch of this, but if you can envision this, if here's the y-axis and this is shifted over 3, remember that the asymptote will be on x equals 3. So when the function comes down, it's not going to touch the axis, and that's why there's no y-intercept. The x-intercept, there would be an x-intercept, and to find the x-intercept, of course, we just simply set the y value at 0, and we do that because on the x-intercept, the y value is 0. So set that equal to 0 and solve for x. And that's what it would be. The range for this guy, let's take a peek at this guy. What would the range be? The range, this is a logarithmic function, so the range, there'd be no restriction on the range, because remember, an exponential function, it's going to go up in both up and down. Okay? Let's see what else we got here. And I encourage you to use Desmos here to help you understand that if you're not sure. And the way you type that into Desmos is you go y equals log shift minus, gets the subscript of the 4 there. Okay, and the asymptote here would be at -1, okay, because we know that that's the cutoff, that's the smallest that x can be. Okay, and the y-intercept here, again this time, let's see, it's going to flip over, and since it's shifted over, there would be a y-intercept here, and again, you just set x equals to 0 and solve for y there. All right, okay. So what we're going to do here is this guy here is going to ask you to determine the inverse of that sucker. So why don't you go ahead and do that? And remember, to take the inverse, we're going to switch x and y. We are going to take the 5 to the other side. We could convert at this point. So the base is 2, so it's going to be 2 to the exponent x plus 5 equals y minus 2. And take it from there, and then you're done. Okay. These are really important visualization questions, and I encourage you to draw this. Oh, let's see. I might be able to draw this. I think I'm going to give this a go. Okay. Okay, so it says, I'm going to just do this real quick. Okay, if b is greater than 0, so let's just choose a number. I'm going to choose a number 2, let's say. If b is greater than 0, what must be true about, so if b is greater than, if b is greater than 0, then it looks either like this or it looks like that, depending on what the a value is. What must be true about the other variables so that there's a y-intercept? Okay, well, we know that the a value simply causes the reflection over the axis, so that's not going to impact. So a would not matter. Does not matter. Okay, the b and the p and the q value, in order for there to be a y-intercept, this has to be shifted over. So we'd want x to be less than 0. So if x is less than 0, so if p is -1, then we'd be over on this side. And there you go. And then the q value would not matter. Okay, so that's what this says. So the p has to be less than 0, and q wouldn't matter. Here's another question. If a is less than 0, so let's do that right away. So if that was minus, what must be true about the other values so that there is a y value, what do you call it? A y-intercept. Okay. Well, in order for that to happen, either let's see. Sorry, that doesn't go like that. It goes down more. Gosh, you got me thinking. Okay, so what must be true? Well, we know that p, if we shift p over, oh, yeah, sorry. Yeah. Okay, what would we have to be true about the p? Okay, the q value, sorry. Okay, p value wouldn't matter at all. P value wouldn't matter. If to shift it this way, so then it would look like that, we'd need the b value to be positive and the p value to be negative. Now another possibility is, I'll do it in green, if the b value is negative, then this function is going to look more like that. And so then what would have to happen is that if this guy's negative, then the p-value would have to be positive, so then it will look like that. And that's why it says this, that q doesn't matter, and that b times p has to be negative, or b and p have opposite sides, so signs. So that's a lot to think about, but that is how I think about it. Okay, so this one says write the equation of this guy. Again, put this on pause. Okay, we're going to lose the pens here, I hope. Okay, good. So I'm going to do this in Desmos for us so that we can see it. Okay, so what I'm going to do is first start off with this. Here's the graph that I'm trying to find, and I'm just going to observe it to start off with. I'm going to see if I can see any patterns. Well, just from that point there, it's going up by 1, and it's going up by 3, and then 1, 2, 3, 4, 5, 6, 7. Let's try to see if we can find some sort of pattern here. 1. Okay, so finding the pattern can be kind of tricky. Just some observations that I make is I'm noticing that, here's the asymptote right here. And I can see that that's going up by 1, and then 2, and then 4, and then 8. So I'm pretty sure this is going to be a base 2 here. So I'm going to do that. I know that I have to shift it back to -2, so I'm going to make that a +2 there. Okay, this is getting better. What else do we need to do here? Well, at a certain, I don't know about you, but can you see here, this is 1 and then 2, and it looks like this has been compressed vertically, so I'm going to put a half in there. Okay, so I'm pretty right on that. So another thing I might do here, just to help out, is I'm going to go x equals -2. And now what I'm going to try to do is figure out where is that first value. Let's see if I can find that. Because that's 1 right there. Can you see that? I think that's going to be an important value. Y equals, what is that? +4. Pretty sure. Yeah, that's looking pretty good. It would be, 2 to the power of 0 is 1, 2 to the power of whatever is, okay, I think I've got that. Yeah, and you can see it's a bit of a fiddling around, but I think if we make this a +4, we should be good, okay? And that's just because we had that horizontal compression, all right? So if we lose that horizontal compression just for a second, so you can see what it would look like, it would still go through that point there at 1. So 2 to the power of 0 is 1. See, those 2 points line up, those 2 points line up, those 2 points line up, and so on. So obviously very tricky, and that'll definitely take some time for you to wrestle with. It's not meant to be done quickly or easily. It really requires you to make observations. You need to take some guesses and assess whether your guesses are on the right track or not. So there you go. So that's a really tricky problem, and looks like we have time for one more. And again, this one would be just being really careful with how you graph this. I'm going to do it for you in Desmos. Of course, you'll do it by hand, but some observations to make here. It's just what the asymptote is to start off with. Let's see if we can graph this. Okay, I would like to graph this. Finally, it opened up. Okay, so first things first, what we want to do on this graph here is just note, let's lose that for a sec. Why is that not going? Okay, yeah. So what we're going to do first, we know that this guy here doesn't change the shape of the graph, and this guy here doesn't change the shape of the graph. So from that point there, all we need to do is graph y equals log shift minus that. We just need to do that guy, but we know that this negative causes a reflection, like so, and this guy here causes a reflection over the y-axis. So those are just things, I don't know how you want to order that, But basically, we're just going to take this basic shape here, and usually we would go, from here we'd go 2 to the power of 0 is 1, 2 to the power of 2 is 2, and so on. This time we actually have to do it the move in the opposite direction, which you can see right here. So let's see if we can help you with that. Okay, so let me get the scale here a little bit better. Alrighty, so remember here we're going 2 to the power of 0 is 1, and we're going down this time. Remember, usually we'd be going, if this was positive, we'd be going from 0, we'd be going 2 to the power of 0 is 1, we'd be going up and to the right. 2 to the power 1 is 2. With this guy, because both have reflected over both axes, it's going to be 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4, and so on. And that's where that green graph came from. So I hope that helped. Again, that's going to be tricky as well. Stay with it. Let us know if you need any support. And that's the end of this chapter as far as I know.